Okay, 5.4.3, the triangle angle bisector theorem. Really a nice result, and not altogether obvious why this is the case. So let's review what the theorem says. If a ray bisects the angle of a triangle, so in this case, ray DB is bisecting angle B, then the opposite side is cut proportionally to the other two sides. So what this is saying for this particular picture is that since this is an angle bisector, it will cut at D in such a way that DA relates to DC the same way that AB relates to CB, right? The pieces relate in the same way that the other two sides relate. It's kind of interesting. And the proof is pretty elegant, so I hope you enjoy it. I could leave it up to you to do it, but it's a pretty neat proof, and it does use the side splitter theorem, I think is what yes. So here we go, down at the bottom, draw parallel to BD through A. So here we go, and we know from the parallel postulate that that exists. Here we go. So these two are parallel. And then it says extend CB to intersect with the parallel at K. So I'm going to take, let's see if I can do this in a slightly different color. I want to extend CB so that it intersects with, let's see if I can do this a little longer. Okay. And so this is point K. What's really nice is that because we created a parallel structure, we also have, way back when, remember your old friends. This course, you'll hear me say this many, many times. Remember your old friends. Remember that with parallel lines, alternate interior angles are always congruent. So parallel, this has a measure which will be exactly the same as this, which is pretty nice. Less obvious might be the fact that because these are parallel and this is a transversal, this angle up here is a corresponding angle with this one over here. The reason why that's super important is that I now have triangle ABK is now an isosceles triangle, another old friend and a great old friend. We've got an isosceles triangle here. And therefore, the length of BA is the same as the length of BK. All right, so that's going to be important in a second. Forget about that for a moment. Now look at triangle, the big one, CAK. CAK has a parallel line through it. We know from the side splitter theorem that CD relates to DA, CD relates to DA the same way that CB relates to BK. Well, what's really nice is that we just got finished saying that BK is congruent to BA. So I'm going to replace it by substitution. And if I take away all the junk now and I look back at the pink triangle, I have now proven that CD relates to DA, CD relates to DA. These are the pieces, right? CD to DA, which kind of is this one back here, right? in the same way that CB, right, the remaining piece of the triangle, relates to BA here, right here. Okay, and so that actually is what we were aiming for. Pardon the fact that I've changed the order of the letters, but you can see pretty clearly that I have proven what I need to prove just by going through creating a parallel line and creating a whole nother triangle and then using the side, splitter theorem.